Welcome to question number 37, the last one from the August 2017 Algebra 2 exam. In this question, we're given two equations. One represents the value of this car, that's v of t, and also z of t, which represents the amount of money that Zach still owns over time. So we're going to be graphing these to start off. Now notice it does say that we do want to graph it over the interval of time being from 0 to 5 years. So we're going to start by labeling our x-axis with those values. And I just spaced them out 3 spaces apart just so it's nice and spread out across the x-axis here. Now, how are we going to actually graph these? Well, we're going to use a graphing calculator to help you out. I don't have like a TI-83 or TI-84 to show you, but basically you would get something that looks like this. You can see the blue graph represents the v of t, and the green one represents z of t. So using the graphing calculator, you should be able to plot the points specifically where t is equal to 0, 1, 2, 3, 4, and 5. Obviously, you're going to have to take some time to play around with your calculator settings so that you can see the y-intercepts for both cases. You'll notice that the maximum for v of t is just about at 30,000, so that's going to be the maximum. We can make 2, 3, 4, 5 ticks represent 10,000, so I'm just going to do 10k for 10,000. Another 5 ticks for 20,000. Another 5 ticks for 30,000. So basically each line here is going to represent 2,000. So if you were using a TI-83 or 84, you would probably utilize the trace function and plug in your x values of 0, 1, 2, 3, 4, and 5 for each graph, and you should end up getting something that looks like what I've drawn here. Okay, now for the second part of this question, it asks us to state when the two graphs or functions are equal to each other and interpret its meaning in the context of the problem. So using your graphing calculator, you would press second trace and choose the intercept option. And then they would go through, first graph, second graph, guess. So you basically just have to press enter a few times, and it'll output the x value of where the two graphs intersect, which, visually it looks like it's at 2, but it's actually closer to 1.95, as you should see in your calculator. And I am rounding that to the nearest hundredth as they ask you to in the question. And I guess I shouldn't use t as our variable. We should switch that to t for time. So the time equals 1.95. In the context of this situation, that means after 1.95 years, the value of the car is going to equal the amount that Zach owes. So the value of the car equals the loan balance. So you can see my written explanation there. After 1.95 years, the value of Zach's car will equal the loan balance, or the amount that he still owes. Now, for the third and final part to this question, we're essentially going to try to look at the value of the car, the black graph that I've drawn, and we want to try to find out when it reaches a value of $3,000 or less, because once that happens, the value of his car is worth less than the deductible in this situation. And we need to find out to the nearest year how long that, or basically in what year that's going to occur. Now, we've already figured out that in year 5, at least you should, since you've already graphed it, you should know that the value after 5 years was about $4,264 if we're rounding to the nearest dollar. So we can see that as quite at the $3,000 mark yet. So it would just kind of make common sense, since we are rounding to the nearest year, to figure out what is the value the next year after 6 years. So you can use your trace function on your calculator. Or if you didn't want to, you could also just replace t back in this original equation with a value of 6 and equate it. But anyway, you should get a value of 2,917. Again, I'm rounding to the nearest dollar. So notice that after 6 years, the value has now decreased to a little bit lower than the amount of his deductible, $3,000. So in the question to the nearest year, how long will it take Zach to cancel his policy? Well, he would cancel it after 6 years because the value of the car is now a little bit less than the amount of his deductible. So you can see my final explanation that I've given here. The value of, the car, so that should say, is about $2,917 after 6 years, which is less than the cost of his deductible, being $3,000, so he would cancel his policy after 6 years. All right, part 3 is complete, and that is it for this video. I hope that was helpful, and thanks for visiting JD's Regents Preparation.